This board here is slightly more advanced than the previous one, which just had a voltage divider effectively. This left-hand side of the board has a voltage divider as well. So if I put in 2000 ohms here and 2000 ohms down here, the voltage coming in here, 6 volts, is split in two. So at the center point we get 3 volts here. If I put 1000 ohms in the bottom, it will be split in the ratio of 2 to 1. So I get 2 volts here and 4 volts here. So the 6 volts will be split in direct proportion to the resistances. Now, on the other side here, there's a transistor. The transistor is a device that can conduct current from one side to the other, provided the voltage on the base is high enough. So a voltage of a volt or higher will turn it on. Below about 0.6 of a volt, it's turned off. So if I put a bulb in here, and if I put a resistance in here, now I have 2000 ohms there, and I have nothing on the bottom. So effectively, I'm getting the 6 volts on here. If I put in 2000 ohms here, it's still on. If I put in 1000 ohms, it's still on. But if I put in something much smaller, like 50 ohms, now it's gone off. The reason is this resistance now is a small fraction of the total. If that is 1/10 of the total resistance, then the voltage here is 1/10 of what's coming in. So whatever fraction that lower resistance is of the total resistance, the voltage here is the same fraction of the supply voltage. So we can vary the voltage here in various ways, but this left-hand side acts as a voltage divider all the time. So for example, if I put in a light-dependent resistor here, and put in, say, 5000 ohms here at the top. Now, the light-dependent resistor has a very low resistance when light is shining on it. But in the dark, or when it's shaded, its resistance rises. So as its resistance rises, the voltage across it also rises. So if that becomes a bigger fraction of the total resistance, the voltage here becomes a bigger fraction of the supply and is sufficient to turn on the light here. So you can see when I put my finger over it, darkening it, the light goes on. So here is a situation now where you can turn things on by increasing resistance. For example, if we have a buzzer here, now if I put in something to keep the voltage down here low, so here I have my reed switch and a magnet near it. Now, as long as that magnet is near it, that switch is intact. And so it has effectively zero resistance. And so it keeps the voltage here on the transistor at 0. But as soon as that circuit is broken here at the bottom, either breaking the wire or removing the magnet from the reed switch, the voltage on the base of the transistor rises and turns on the buzzer. So this is the opposite of what we had earlier in the simple circuit board. Here is a case of turning something on by breaking a circuit. You could also do it with a simple wire. If you have an alarm system and you have a wire in your house that goes around from one door to the next to the windows and so on, as long as that wire is intact the whole way around, it keeps the voltage on the transistor low. But if somebody cuts that wire or removes it, then the alarm sounds.